They see dollar signs.
This is only the start of this.
It's a growth environment.
It's very massive.
That defines what is high quality.
I'd say overrated and underrated.
We don't need the prize money. Oh,
It's nice to have.
I want to win it because I'm competitive.
We have no difficulty destroying those.
We speak to people.
the next one's gonna be a little tougher.
That literally tells you the steps.
We can call it the Water Olympics.
3 days is barely scratching the surface.
We're trying to become the internet of water for the US.
If they really want to take it out, they're doing it all wrong.
Dumping them on ChatGPT.
That might be a reason why there's not a good fit.
If you feed it garbage, you get garbage out.
So let's not do that.
We've never had customers like this before.
What needs to happen is happening.
Yeah, you're good at this.
Best WEFTEC ever.
Welcome to Chicago, where 1,000 exhibitors and over 20,000 water professionals convened for what is and was a fascinating and exciting WEFTEC 2025. As always, I did my trick on every trade show to go find 5 technology picks, which I'll share with you today. But also, we'll talk about AI, which was very present this year. We'll look at the do's and don'ts of trade show marketing and drive to booth. I collected a bunch of bits and pieces from all around the floor, which I'll share, of course. But I also met with some of the XPRIZE nominees, and while I take the Metra to go to the conference center, let me fill you in on what XPRIZE exactly is in a voiceover. $119 million, that's the largest incentive in XPRIZE's history, and it will be paid out to the winners of the water scarcity competition that's running since March 2024, and which just announced its 143 qualified teams from 29 countries that advance to the next step of the challenge. The overall goal is to develop and reward reliable, affordable, and sustainable seawater desalination systems and methods across 2 tracks: a System 1, where the contenders will need to produce 1 cubic meter of water in the next phase, and a Material and Methods track, where teams will validate new membranes and separation technologies at laboratory scale. Oh wait, I think I arrived? Actually no, it turns out I took the wrong train. Which, on the bright side, gets me the opportunity to discover new beautiful places in Chicago. Awesome, so let me use the time to finish my explanation. Teams will then be judged on criteria such as operating cost, environmental performance, market potential, or integration compatibility, with the next trim that shall select up to 30 semi-finalists at the beginning of next year for a piloting phase in the second quarter. Finalists will then be announced at the end of 2026, while down the line at Climate Week 2027, the winners of Track B will share $10.5 million, and the winners of Track A the other $108 million. But who are the contenders? Quite some alumni of my podcast, such as Capture 6, Flotion, Gradient, or Nala Membranes, and probably more that I might meet if I ever reach WEFTEC's building, right?
One eternity later.
Okay, so now that I made it, let's go meet some familiar faces that got shortlisted for XPRIZE.
XPRIZE is an exciting innovation contest that helps bring the global community together to solve a problem and put some money behind it, which is awesome because often we're tasked as technology companies to solve a problem without a reward at the end or a maybe reward. And now it's an actual reward. And it also canvasses everything from universities to entrepreneurs to big companies to medium-sized companies like Aquamembrane.
We are one of the shortlisted entrants for Track A of the XPRIZE.
I've been on it since, the very early announcement of XPRIZE. We have qualified for both Tracks A and Track B. We're building and upgrading a system right now for Track A. We'll be running it in a naval base in Port Hueneme, California. And then we're also on Track B. We're developing our next generation active membranes.
Super excited. We made it through the first cut and then the cut downs to 20. And that's really what we're banking on because we know we've got the energy savings to prove and we're already building the pilot. We hope lead to at least a 3 to maybe as much as 6% energy cut in standard elements versus printed spacers. And one of our first published data is on seawater desal. We've got a skid on the way. We're going to run it through the end of the year and we'll publish data.
What are the next steps for you?
Develop our application, develop the process. We are committed to making CO2 desalination not just efficient, but also practical and scalable to maximize access to this technology in the most water scarce regions.
It's going to be in our facility because this stage you don't need a lot of volume. Then it goes to 1,000 and then 10,000 in the future. We bought a specific machine that interestingly was already paralleling our product development. So for us, it was like kind of a nice coincidence.
Is it a technology which is already existing, or are you developing it specially for XPRIZE?
We are taking a holistic approach to the desalination process, from intake through to brine. How can we make our intakes minimize their impact on the marine environment? How can we ensure that our pre-treatment is doing everything it can to improve the energy efficiency and reduce the chemical consumption?
The next one's going to be a little tougher. The next one's a bigger investment. It's actually building a field pilot, which we'll likely do as ourselves, but our technology lends itself for partnership. If one of the other OEMs or equipment makers want to put our membrane in with their innovative solutions, like active membrane or gradient or some of the other finalists, yeah, we're open to that too.
We're also looking at what we can produce from seawater brine, what chemicals can be made, because that then improves the commercial viability of the brine mining operation. How do we bring a practical, scalable, and elegant approach to a new generation of seawater desalination?
What are your hopes?
Everyone loves to win. Everyone loves to be a finalist. We believe we have the best submission.
I'm hoping that we make it all the way to final, but overall, it's such a motivating force in this industry.
But the most important thing for us and for the XPRIZE in general is pushing forward the horizons for seawater desalination.
As far as innovations in this field are concerned, I don't think any team will find a better platform than this.
Everybody told me stuff around the lines of everybody wins.
So if one of the OEMs wants to use our technology, they win the prize, God bless them. We'll be glad we helped them win because we'll win in the end because it'll be a great validation of aqua membranes. We hope everybody uses aqua membranes in their system.
But come on, 40 million.
It's nice to have, but if you look at the opportunity on the table for the world in pushing forward desalination, I think it's a win-win situation for everybody involved.
And obviously, I'd like to go all the way to the final and win it, but time will tell.
We don't need the prize money. Well, we would love the prize money, but we are looking for much more validation of the technology.
Beyond money, this is something good for this industry. We'll put on our best shoes and we'll put on our best effort, and I want to win it because I'm competitive.
I think on the component level, we rank very high. I have a lot of confidence we'll get into the 20. From 20 down to 5, that's going to be a tough cut for us.
Rory, you're brilliant at answering greatly weird questions. Thanks a lot.
Wonderful, thanks very much.
Crossing my fingers for you. Here we go. Thanks for the update.
Thanks, Antoine.
Crossing fingers for you.
Thank you.
All the teams are out there working their butts off.
All the teams were wonderful.
Start this top 5 with number 5, I need to preface it because actually they have been harassing me over the past months and maybe years to get me to talk to them. And I certainly don't want to reward harassments, but I gave in, I spoke with them, and I have to say the tech is interesting. So I don't want to reward harassment, but I think it belongs here. So let's have a look at BDP and EnviroTech.
The lines of technologies.
Okay.
The one line is the aeration system. The aeration technology delivers a unique and advanced way of aeration through the basic diffuser and automation system.
What's special about the diffusion?
The diffuser actually serves, as we can see, very uniform air bubbling.
I see.
Delivered by this membrane diffuser that we manufactured in Southern California. The diffuser actually having the pores on the membrane style diffuser, which actually delivering in wastewater condition, 40% oxygen transfer efficiency. OTE Institute.
Okay.
Tested by off-gas testing technology, maintaining a high oxygen transfer efficiency by design and installation and operating the system by just turning the air off, half number of the aerators, normal air,
yeah,
and by water pressure it's going to collapse, making it like a sleeve to clean the pores. The other half of the aerators, they get double the airflow.
So what you're saying is basically like when you have your shower heads and you're rubbing it to clean it.
Yeah.
Except here the water does the hard work, puts the pressure on it and rubs it clean.
Yeah, yeah.
And that way you don't have like biofouling or whatever.
Right.
Okay.
We have a way without shutting down the plant to clean the aerators.
So all you need basically is 2 automatic valves. You're switching from one to the other and it does the cleaning.
Twice a week and 5 minutes each time.
And so that is a one-to-one replacement to the usual aerators you find in a biological plant.
They're either discs, panels, or tubes. Yeah.
But still, it's a membrane. A membrane has a lifetime.
Yep, it'll last over 10 years. Because the major damage of a shortened life cycle of the membrane is once drain the basin, power wash, and plus the UVs from the sun. That will damage the plastic. We don't need to do that over the life cycle of the aerators. Once they're installed in the water, we don't see them again.
I saw you just rolling it out, so I'm assuming it's a brownfield technology.
Retrofitting and the greenfield projects are both applicable. With a conventional disc or a panel or tube aerators, once one disc or one aerator is broken, they have to shut down the entire plant to replace it. With our technology, we can put it out during operation time.
And you said the transfer efficiency is
40% in wastewater condition, double a conventional aerator. And they're in the range of 15 to 23%.
If I play the devil's advocate, I like the simplicity, but it also sounds like I can take 2 valves, a tube, garden hose, put holes in my garden hose, and I have a diffuser.
The main problem is the garden hose, they're much thicker. The special material and the special manufacturing.
So the special material is the differentiator.
Is the special PU, very thin wall, 0.35 millimeter thickness.
Is it a proprietary material?
It is a proprietary material.
Okay.
Yep. And also the way we manufacture it.
You mentioned 70 installations. Is the 70 installations of that? Yeah. How many countries?
US, India, China, Taiwan, and then Serbia and France.
So you said that's 1 out of 2. So what is number 2?
The process is probably even more interesting that it is the first of its kind. We don't separate the anaerobic and aerobic conditions, but combine nitrification, denitrification into one tank.
Okay.
And also integrate the clarifications section into the same tank.
Nitrification, denitrification, and clarification in the same tank.
In the same tank.
Okay.
Now our process is one tank, same tank, but it's a continuous process. Nature has never been divided into anaerobic and aerobic water bodies.
Makes sense.
The bacteria living there have been around over 1 billion years. Why human being we have to separate the natural supply bacteria into a different environment for the bacteria? Why not go back to the nature? That's how we did it. So we put everything together into the same tank, giving them a simulated environment as in the nature, and they just reproduce better. We have been able to breed the bacteria with a much higher mixed liquor concentration to somewhere between 6 grams up to 10 grams per liter, and at the operating condition of 0.3 milligrams per liter of dissolved flaxseed.
Okay, but how?
The first thing very important is having the mixed liquor circling back continuously to dilute the influence of a wastewater, providing a much diluted and low impact to the bacteria inside the tank. If we collect samples inside the entire system, everywhere the COD or organic matter concentration from the influent is more or less the same, which is very different. Conventional system from the intake side, the COD is much higher.
Yep, and then you have a curve and it goes down.
Yes, yes, we're very flat. Dilution method is actually just by air lift, which receives the same air flow from the same blower for aeration.
Is it because the tank is homogeneous? Then
smaller, homogeneously.
Okay, smaller and homogeneous.
Yeah.
But how do you deal with the different type of bacteria? The one which would be aerobic, anoxic?
The seeding sludge normally we get is just from any conventional wastewater treatment plant. Over about between 2 to 4 weeks time, they will restructure the bacteria flux into a slightly denser and smaller flux by delivering lower concentration and less food.
You bring
bacteria
a balance to the bacteria density because you don't have like the big eaters and the small eaters. You have like all the medium eaters, which makes me think of the mechanism you have in a membrane aerated bioreactor just without the membrane.
That's right. The impact to the bacteria is lower, and then they tend to grow slower. Once they grow slower, they also grow thinner biofilm. That will allow them to grow with a higher population, number one. Number two, the penetration of a DO and also the organic matter to be absorbed by the bacterial flux also increase the efficiency.
That must reduce the amount of sludge, so you can downsize the sludge line.
Yeah.
But would that work with any kind of load? Like you have an industrial park with a hard COD, it's not a problem.
It all depends on how we design for a particular type of customized for wastewater treatment to deal with a particular waste.
So you would do an adaptation of the design to fit the specific load.
Right.
I see.
For a higher concentration of industrial wastewater, we will need to dilute with a higher ratio.
What is your scope of delivery on such a project?
Most of the project, our business model, we just deliver the technology, which comprises of 2 parts: process design, and then the proprietary systems, which includes the aeration and airlift, and also the automatic control system. The engineer firm will take over from our design.
Does that mean you're giving guarantees?
We will give guarantee on the effluent quality.
When you have that conversation with an engineer, the activated sludge process is 110 years old. They know that in and out.
Right.
And you come and you say, you know what, let's do something else. How do they react to that?
Most of them are quite surprised that there's still something new coming out after over 100 years.
It's something you can show on screen. So you're working with the big guys.
And they asked us whether they could do a comparison and an evaluation. But they did.
Okay.
That was it.
They didn't come back after that? Which you see as a good or a negative sign?
It's all about business.
That means you're going in direct frontal competition to an MBR.
We deliver the sludge concentration as same as in MBR. We deliver the same basin size and with much better result on nutrients removal, like total nitrogen removal. much higher than NBR. The only shortfall of our process compared to NBR is a TSS.
Because you don't have a membrane. And
right, we're non-membrane. I mean, TSS is easy to be taken care of with a very simple tertiary treatment. The main problem, nutrients removal.
In 2030, where do you see BDP EnviroTech?
In Northern California, we're working with Silicon Valley Clean Water, which is a test pilot project. They're trying to test and work together with Stanford University.
Okay.
The aim of the project is to upgrade and retrofit their existing wastewater treatment plants to meet the new regulation by the State Water Board on nitrogen removal. We're in the right track. In the Bay Area, there are 37 wastewater treatment plants around the Bay Area.
Yep.
In 2033, they are required to meet the new nitrogen removal requirements. We have a huge potential to having a conversation with all of them. The testing now is in Silicon Valley, it's in the Bay Area. And then by 2030, we may have a lot of projects, not only in California and Bay Area, but potentially all over the state and nationwide.
What is the deadline, like the milestone?
Early next year, probably. To vision ourselves, in 5 years, probably you will see 10 projects to 20 projects in India, maybe 20 projects in the US. And we'll grow many folds in the next 5 years.
Thanks a lot for the tour. Thanks for the explanation. Looking forward to the next milestone.
Thank you so much.
So for the technology picks, of course, I could not skip PFAS. I have several of them, and you'll see that they all have different flavors of ways to tackle the PFAS challenge. Let's start with Lummus. You have a PFAS destruction technology, but how do you do that exactly?
We destroy PFAS through electrooxidation. We use boron-doped diamond electrodes to create hydroxyl radicals and also a potential on the electrode surface to completely mineralize PFAS down to its basic building blocks of sodium fluoride and sodium carbonate.
People tell me whether the electrode is the secret or the reactor is the secret. So what is your best weapon?
It's definitely the electrodes.
Okay.
The electrodes that we use are different than any other electrode in the market. When I say boron-doped diamond electrode, I mean boron-doped diamond electrode all the way through. It's one continuous diamond throughout the entire electrode. We're not putting a nano film coating onto a substrate. Our thickness is in millimeters of diamond that we put into our electrode. What that allows us to do is to go to current densities that nobody else can. And that's really important in the destruction of PFAS.
When you say that no one else can, that means much more or much less?
Nobody else can go to that high of current density. Current density, it's amps per meter squared.
Okay.
So it means how much electricity, and that is proportional to how much oxidant we can create and the potential that we can create for oxidizing things. That allows us to oxidize things that other technologies cannot. And it also, some electrooxidation technologies have difficulties with short chain PFAS.
Like TFAs or?
TFAs, but even the C4s.
C4s, okay.
PFBA, PFBS, we have no difficulty destroying those. We had a third-party university do a study for us and created rate constants for us to destroy those. We go 2 orders of magnitude higher current density than anybody else in the marketplace.
2 orders of magnitude?
Yes.
Okay.
If you look at conventional electrooxidation that uses maybe metal electrodes, they'll be in the hundreds of amps per meter squared.
Mm-hmm.
We can go up to close to 40,000 amps per meter squared. So the fact that we can go to that much higher current density makes our system much more compact. When people hear about boron-doped diamond, they see dollar signs. We have such high current density, we use that 2 orders of magnitude less electrodes. That's another way to look at it.
What you're saying is that the material itself might be expensive, but if you need so much less of it, then it compensates, and it means that you're still cost competitive.
Yes. And you could also imagine if you had a nanofilm coating of boron-doped diamond on something versus having millimeters thick of diamond, how much longer our electrodes last in the same environment than a coating. We've had this technology for more than a decade. We've applied it in many different industries. So this is not a new technology for us. Applying it for PFAS was the new part.
Did you have to do some adaptations and new developments to take it to PFAS, or is it really the tech you had around for 10 years?
What we had to do is develop the kinetics and the understanding on what's required to break down the PFAS. The technology itself, if you look at the flow scheme and all of that stuff, is the same as it's always been.
Okay.
It's just now we're understanding how much energy we need to use and the economics behind destroying the PFAS.
What about the hydraulics? Because having the power density at a specific spot is one thing, but you need also to ensure that the right amount of water flows by the electrodes. How do you guarantee that?
We operate in a semi-batch mode. While we are treating one tank, we're filling another tank, and then we can switch back and forth. We size our system to be able to treat that tank down to the level of PFAS required by our customer. Mm-hmm. And once treated, then we drain that tank and we switch over to the other tank. So what we're doing is taking this tank of fluid and flowing it through our reactors. So our reactors are flow through. They're not sitting in a stationary mixed tank. We're actually pumping it through our reactor. That's kind of key to our design.
You mentioned your customers. So where are you in terms of market deployment?
We have commercial references for the technology. We switched over to looking at PFAS.
So commercial references for the technology, but not in PFAS.
Correct.
And now you're looking at PFAS.
Yes, and now we've done many pilot studies in many different industries on PFAS, and we're doing those pilot studies at the commercial scale. We have a test unit in Texas that allows us to bring samples in, treat it with electrodes that are at the commercial scale, and demonstrate our performance.
And what is your scope of deliveries? Are you selling an electrode? Are you giving a full PFAS destruction as a service? Where in between those two extremes?
So for electrooxidation, a concentration step is necessary. Lummus is prepared to offer the electrooxidation, of course, and that's a modular supplied equipment. We will also supply the process guarantee from the concentration step through the destruction step.
Sorry to cut you, but are you concentration step agnostic, or would you go for foam fractionation, nanofiltration? What's your preferred one?
Up to this point, we've been concentration agnostic.
Okay.
And that's simply because we believe that all of them have merit. There's going to be instances where media is the right answer, where foam fractionation is the right answer, where membranes are the right answer. We just wanted to have a broad understanding of all those because, as I said, we will offer the process guarantee through those, and we will have our partners provide the concentration step.
So that means what you're guaranteeing is a 99 point something destruction of PFAS.
What it comes down to is it's really the water quality, right? That's why we're doing this. We want to destroy the PFAS, but really it's the water quality that the customer cares about.
So it's not a reduction rate, it's you're gonna hold the water quality standards for the specific application of your customer.
We not only guarantee that we're going to get the performance, we're going to produce this much water with this quality, and we're going to dispose of the PFAS, but also at what cost?
Do you have a feeling for the cost today? How does it place itself on the scale compared to all the type of technologies?
Yeah, so we're excited about that. I think the boron-doped diamond, just the sound of that sounds like a high-cost technology, but because we're able to use such a small amount of electrodes, the economics really do make sense compared to thermal technologies and to other electrooxidation technologies. Our early indications are that we outperform them. That is something that we've been working with a lot of customers recently with looking at real examples, working through what our process guarantee would look like, what that would cost them, and the feedback has been really great.
What is your typical application?
Our technology makes a lot of sense for applications that have a lot of background contamination. So things like landfill leachate, wastewater, industrial wastewaters, things like that have a lot of other things in there that none of the electrooxidation technologies are selective for PFAS. Whatever other COD is in there, whatever other contaminants are in there, also have to be destroyed. Oftentimes, it's those other contaminants that end up sizing the system for us.
I see.
We stay away from applications that, if you can manage it with a media, and that media can be recycled in some way, that's difficult to compete with, and PFAS destruction is probably not required, particularly not on site, right? There's a very good business model for taking media in and media out. So we tend to stay away from those kind of municipal applications for like drinking water, those sorts of things. The bulk of our applications are in industrial type of applications.
Take me to the future. Where are you in, let's say, 2030? What is Lummus by then?
We're already making some pretty serious advancements on the technology. We're excited to be able to talk about those soon. Not to give anything away, but that, we may not always be concentration agnostic. We may have some things in there that would help us. We're also looking at ways to produce the electrodes in a fashion that right now our electrodes are all flat. And we're working on ways to have it have a little bit of shape to it.
What needs to happen in the next 12 months?
What needs to happen is happening.
You're not ready to announce your pre-filtration, but I can guess that is something which might be gonna come in the next 12 months.
We expect it to. Yes.
I don't want to push you in a corner or give you a yes, no, just to understand.
We will definitely be pilot testing with customers in the next 12 months, yes.
Thanks a lot. Before moving to the next picks in my top 5, let me remind you of my rules. You can't pay to get onto my microphone. I've never accepted any payment from all the companies you hear over here for 272 weeks in a row to get onto the mic, and it's not gonna change anytime soon. My picks and my podcast invitations are genuine, curious, independent, and reflect my own subjectivity, and this is made possible by the companies that support that philosophy, starting by today's sponsor, SimpleLab. Testing water and everything around it should be simple. With SimpleLab, you choose what to test, from drinking water and wastewater to soil, air, food, and surfaces, and they handle the rest. Kits arrive at your door with free round-trip shipping, samples go to certified labs, and results come back fast, concise, and actionable. Trusted by leading brands and growing teams, SimpleLab offers hundreds of ways to better understand your environment. Get started today at gosimplelab.com. It's the first link in the description. Thanks SimpleLab for supporting my work, and back to me. And now, before moving to my number 3 and 2, we're at WEFTEC, so let's have a word with a WEF board member. WEF board members are obscure people which most of the people don't know, so maybe you don't recognize him, but let me introduce you to Mr. Walid Khoury.
Hi, Antoine. I'm not sure about the obscure people. I was DJing, like WEF board members are everywhere. They sang in Jamming for Water. We were at the YP's Young Professionals, and if you are a young professional, you should join the WEF Young Professional because it was really fun. So we're everywhere, like you can find us everywhere when you come to WEF.
I was stupid enough to miss the opening ceremony. I walked the building, didn't find Walid DJing.
Next year we'll try to make a better job because I think they'll bring me back after you'll have the chance again to see it. Maybe you should do more communication and advertise it more as a standalone activity. This is one of the biggest competitions of water. You can call it the Water Olympics. The Operators Challenge, you've got hundreds of people competing for different applications in terms of servicing our water. And we don't see it, because usually people, they think water, just you open the tap and you get water and then you flush the toilet, But it's much more complicated than that. And these are the guys who are really the heroes of the whole show. WEFTEC is not just about the exhibition, It's much bigger than the exhibitions. You've got the global stage where you have all the discussions globally. You've got the Danish pavilion, the Canadian pavilion, all type of from all around the world. You've got the circular water economy, which is one of our strategic pillars, is where you are trying to reduce and recover nutrients and energy and water, but also regenerate, where you give back the water to the environment. And you've got, of course, the innovation pavilion. So WEF is not just about the AI or about the Operators Challenge or the exhibition. It's much bigger. It's a 30,000 member organization. There are so many technical papers and conferences happening also on the back end of the whole. It's a Davos of water.
Yeah, I think I heard that somewhere.
My stupid press pass doesn't give me access to that side you're advertising.
You can work on it for next year because really the technical papers are put by all our volunteers and communities. This whole event is based on learning and technology sharing and experiences. So it's not just about advertising products. Unfortunately, today we don't have lots of venues who can host WEFTEC. It's very massive. It's the biggest global show of water around the world.
How do you explain that it keeps growing?
The most important part is the community. Not just an exhibition, it's a community. We're the largest annual event. And thank you, Antoine, for being here. I know you're traveling all around the world, and I appreciate that you take the time and come and visit WEFTEC because it means a lot to us, having somebody like you here.
I'm having so much fun. There are trade shows and conferences where it's draining. I'm thinking, why did I commit to that? This one is just fun.
Yeah, it's fun. Yesterday I had a fun exercise at the hack booth. I did some testing.
I saw that.
Today I'm going to do the test, how we do the test and how do we use it. So I'm today with Professor Matt. Now today it's Professor Matt, And there is also the Lego mini figurine. I don't know if you had the chance to see them.
I have a lot of B-roll of that. Let me overlay it right now.
There are a lot of fun activities, not just the work, but also the fun part. And this is what makes a community. Antoine is taking a video, guys.
No, what? Say shit. Don't forget me.
Yeah. We love you, Antoine.
No,
It's the best.
WEFTEC was really a bad place. Okay, my fellow water content creators, Björn Otto, Jim Loria, Alex Passini, and, of course, Walid Khoury didn't fall into my trap, so let's go back to my top 5. We had left it at PFAS destruction with Lummus. And if you believe PFAS destruction is still one bridge too far, let's go to EnviroLabs to talk removal. I see 8 times better PFAS removal. Compared to what?
Compared to the conventional technologies. Everybody here is so focused on the legacy technologies, granular activated carbon, ion exchange resin, but those were never designed for PFAS removal.
While yours is. You designed it only for that.
Specifically designed to have the best selectivity in the market to target, capture and concentrate PFAS.
So what's the backstory? How did you come up with that?
The idea is actually from our CTO, the professor of chemistry, and he heard a lot about PFAS. He's actually an expert in organofluorine synthesis. And he was looking at the water sector and thinking, if they really want to take it out, they're doing it all wrong. He set out to design something that would be specific to PFAS would capture it comprehensively, and that's how we came up with the technology.
But I thought that activated carbon and ion exchange is good enough. So why would I care that it's 8 times better?
I would argue that that's not good enough. Ultimately, we've created a challenge here with PFAS contamination that is not only has all the adverse health effects that people are aware of, but it's very persistent. This is going to stay with us for decades. We're still producing significantly more than we're taking out. In the end, we actually hear from engineering consultants, from utilities, they would like to see more comprehensive removal, and that's what we're offering. So I would not say that is good enough. It's my fear that people think it's good enough.
What I see on your graph is that you're higher, but you're also flatter. Like others will be having different efficiencies depending on, I guess, the type of PFAS, whereas you're stable across the board.
Yeah, and that's because our capture is comprehensive. So whether that's long chain, short chain, or even ultra short chain PFAS, ultra short chain is not on this graph, by the way.
So no TFAs and...
We've tested for that, but that wasn't in this specific case study. While you say flatter, yeah, but that's okay because it's near complete removal.
So tell me about the regenerable. How do you regenerate?
Our technology is actually incredibly robust and resilient. It operates in a variety of water characteristics, different kind of waters, but the regeneration, we can do it in multiple ways. We can apply salt washes, but there's a lot of sites or destruction technologies that don't really like that. But because it's also firmly, incredibly robust, we can use water, but as long as it's at an elevated temperature. When the binding strength of PFAS decreases, and we can wash it off with water.
What is elevated temperature?
Our material is robust to over 200 degrees Celsius. I can see where that question is coming from. If you think, for example, of ion exchange, those resins decompose at, I guess, 40 degrees C. We can go much higher. So that means that elevated temperatures means that wherever we have sufficient decrease in the binding strength so that we can use water.
So your process is a batch process where you would be running the elimination and then at some point it's saturated. You backwash with that elevated temperature water and then you send that to a destruction unit.
Yeah, that would be a option. The thing that we market and position is the right to use our technology. I have a laptop here. It has a sticker on it that says Intel inside. That's where we would love to be with the big technology providers.
So that means Veolia comes to you and says, oh, I have that process with my ActiFlow carb, but I think your adsorbent is going to be better. I might switch one for the other. And then do you sell them the product or the right to use the product? So would they go with their recipe too?
We would sell that in a package. There's a lot of companies out here at WEFTEC that can design filters and everything around it really, really well. Our technology is pretty flexible in the sense that we are technology agnostic. You can use it in a suspended form. You can use it in a packed bed filter. That would also mean that in that scenario, if it takes us years and years to convince people and they already built a, let's say, carbon plant, we could be able to swap out that material and enhance that performance significantly.
Tell me about your go-to-market. How do you convince people to adopt you?
Our technology is now out there with these technology providers for evaluations. And essentially, they bring us the cases.
Can you give names?
We sign pretty strict NDAs. We have some preliminary data. There should be more data available at the end of this year. A handful of these technology providers are evaluating our technology. And essentially, they have certain case studies, whether that's a drinking water application with high amount of short-chain PFAS. They were not removing that. They say, oh, maybe you could do that. Were the challenging things for these technology providers they bring to us. We get a go at it, and then we can see where that takes us.
You can do what the conventionals cannot do, but you do it much more expensive.
I would ultimately argue that with this regeneration, we go to lowest life cycle cost. So we've demonstrated regeneration at least for 5 cycles. We can do it on site, which saves a ton of transportation costs. And that means that the cost for using this, combined with the ease of use, make it a very strong solution.
How do you know when your technology is saturated?
Because we are insensitive to co-contaminants, it's much easier to model when our material would be saturated. Others need a lot more continuous testing. The moment that you roughly know your influent conditions, you can time it much more specifically.
So when you say roughly know, it means you need to know the PFAS loads in the stream. So you still need a PFAS measurement.
Sure, you need some measurements and you do need that information. what we're seeing now is that all these pilots are taking place, all these cases are being studied before technology selection happens. That gives you a ton of information, but now you're much more reliable. And if there's high organics at some point, that's fine. You still need to address those. Our material won't touch that. So that means that it's just PFAS focused.
Take me to the future. Let's say 2030. Where are you in 2030?
I hope, and I hope that also for the sake of society, that comprehensive capture gets much more traction. Instead of focusing on just maybe one or two or a handful of compounds, while there are tens of thousands out there, I hope that the sector moves to that comprehensive capture. And that means that we are in a great position. At that moment, if we do not already have a significant market share, we'll be in a great spot to go and swap out those inefficient technologies.
That's the vision for 2030. Now we reverse engineer that. What needs to happen in the next 12 months?
I can't wait for our current evaluations to wrap up. We have a few big grant applications that I would love to hear the yes on. And then we are in a position to go and meet that demand of these technology providers. When we do that, we can scale. So that means that next year we're looking at 1 or 2 projects. That's a very realistic step up and then move up from there.
Awesome. Thanks a lot for the explanation and looking forward to that. You liked my conversation with Grosswan Technologies last year at WEFTEC, so I thought, let's go for another algal-based technology with Algafilm.
It's a very similar technology to what Grosswan is doing in that we're growing an algae biofilm in order to remove nutrients from wastewater. The primary difference is that our biofilm doesn't move, so it's a stationary system that grows on these lovely cones suspended on cables. A stationary biofilm, mechanically simpler system that allows us to basically bring the cost down by a substantial margin. So we think we're the most cost-effective nutrient removal solution out there for small and medium-sized wastewater treatment plants.
Take me through it. How do this cone actually interact with the water?
We deploy the cones basically suspended on cables. We call it the algae forest because it's a collection of cone-shaped trees, if you will, that just provide a large surface area for the algae to grow on, exposed to sunlight. So algae are photosynthetic. They grow based on energy from the sun, and they capture the nutrients out of the wastewater. So we bring the water in contact with the biofilm by irrigating. So using standard agricultural irrigation equipment to sprinkle the water onto the field of cones. That comes in contact with the biofilm and sponges the ammonia, nitrate, phosphate out of the wastewater in order to produce discharge quality water. You can apply the technology in a variety of different applications, either treating like a primary effluent for massive loading of nutrient removal, in a tertiary effluent for polishing the last little bits of nutrients down to low discharge standards, or in a side stream application taking, again, higher loadings of high concentrations of nutrients and removing those before they get returned to the headworks. So basically 3 different applications for removing nutrient loads from wastewater.
And could the cones basically be anything, or they had to be like that specific shape, material?
The shape is part of the proprietary process. It's optimized to get the optimum amount of surface area per unit footprint in order to allow the algae to convert sunlight into biomass most efficiently. If you lay a biofilm out on a flat surface, it basically gets a sunburn. It can't process all the photons efficiently. It gets photo-inhibited. The ratio of surface area we have in these has been custom designed in order to basically get the algae to the optimum spot where they convert the most energy into biomass, remove the most nutrients per unit footprint, and make the system as compact as possible. One of the strikes against algae-based systems, historically, the algae ponds in particular, is that it takes too much land. By concentrating the surface area vertically, we're able to shrink that footprint down by a factor of about 5 compared to what an algae pond would need. By keeping it as mechanically simple as possible, we think we can bring the cost down by a factor of about 5 compared to some of the more complex photobioreactors that have been developed over the past decade, more for the biofuels industry. So we think the wastewater industry needs something both compact but simple and cost effective, especially because smaller municipalities don't have a lot of operations staff. It can't use a lot of operating hours per day for someone to babysit. So it has to be a simple, cost-effective system. And that's really where we think we gain our efficiency.
To what technology do you compare yourself to? Like, what do you compete with?
There are a few other algae-based competitors out there, but the sum of us all together are a minor fraction of...
Algae-based is a niche.
Yeah. It's a growth environment.
It's a growth environment.
The bulk of the nitrogen today is removed bacterially with nitrification, denitrification, MBBRs, there's nitrogen removal enhancements you can add to a lagoon. Biodomes, biocords, saggers, all these different types of systems that have been invented to sort of augment the nutrient removal capabilities of systems that have been built maybe 20, 30, 40 years ago when nutrient regulations weren't really present, but to upgrade those systems to meet modern nutrient regulations. So we think we're just a better, lower energy solution to achieve that same outcome.
So that means you're a brownfield solution?
I think initially that's probably the bulk of the market. You can always put it in as a greenfield, but I think the reality is the bulk of the market today is the brownfield market. It's upgrades, it's augmenting the capacity of a system to match population growth, industrial growth, or a regulatory change.
I'm not going to ask you to tell me about your pilot because I'd rather see your pilot. I'm too close to it to ask you about it. But your full scale is far enough that I can ask you about it. Tell me about your full scale. What's the story?
Our first commercial demonstration, we're building it in conjunction with Ontario Clean Water Agency and the town of Kingsville in southern Ontario. It's going to be treating about 100,000 liters per day of primary effluent wastewater, targeting removing about 80% of the ammonia. It's, in our case, our first commercial demonstration of the technology, and we think we can use that as a reference point to grow to the Great Lakes region more broadly and ultimately more the whole Mississippi watershed. The Ontario Clean Water Agency was actually the key to bringing us in. The particular municipality is home to the hotbed of the greenhouse vegetable industry in Canada, so the growth in the area has been way ahead of plan as a result of the growth of the greenhouse industry, both because of the population of workers that they're bringing in to work in the greenhouses, but also the blowdown from the irrigation water from the greenhouses themselves. So the nutrient loads in the local area have been exploding to the extent that the treatment plants in the area have reached their treatment capacity much ahead of schedule.
What's your business model? Are you selling cones? Are you offering a treatment as a service? Are you?
Initially, at least, we need to sort of offer a full package system. So yes, we're selling the cones and the suspension systems to hang them. We can provide the process skid in a container, so the pumps, controls, electrical as a capital sale. There will be some maintenance sale of the cones, but we expect them to last about 5 years to 10 years. So that'll be a relatively minor part of the business. So primarily a capital sale business model.
And do you seed them, or how does that work?
They actually seed themselves. It turns out there are algae pretty much everywhere, including in most wastewater. We're not trying to select for
That's not a good business model.
We think there are some applications where there will be particular culture, like in more specialty products area. So we think eventually, as we build this, we think we're developing a more cost-effective platform for producing algae in general. So there may be applications in the nutraceutical business, for example, where we can sell this to algae producers. You can see that with specific strains of algae for particular bioproducts. But in the municipal wastewater business, trying to farm specific designer bacteria or algae is a pretty challenging proposition because there are just a lot of native species in the wastewater that will generally outcompete whatever you try and maintain.
And in terms of operation, is it like self-operating, or do you need to reap the algae?
You do need to harvest the algae about once a week, but that's an automated process. So in our case, there's a traveling bridge that comes across and sprays the biofilm off for collection.
So the algae is not moving, but
the harvest mechanism is, the algae growth is continuous, whereas the harvesting happens approximately for an hour every week. By moving the part that doesn't happen as often, we're minimizing the mechanical complexity of the system.
And when you harvest it, what do you do of it?
It falls to the floor under the cones, flows into our irrigation collection trough. Because it comes off as a biofilm, it's like lumps and clumps. It settles within about 5 minutes to about a 2% solid slurry. So we're able to send that directly to the typical biosolids handling equipment, the thickening, dewatering, and storage equipment that the wastewater treatment plant already has. The commercial plant is in construction currently, so we have a 3D model of it. But 2026 will be our initial operation for the commercial model, and then getting into our commercial sales following that.
So what do you need to demonstrate on the demonstrator commercial plant in Ontario so that then you can roll it out further?
The demonstration plant's a 50 times scale up relative to what we're doing in Vancouver. So it's the first installation to use all the full commercial scale irrigation equipment, harvest equipment. It's really our proof of concept that all the commercial grade equipment works. From there, it's just really a cookie cutter modular system that we can expand in capacity. The individual cones themselves, we're already using the same cones in the pilots in Vancouver as we'll be using in Kingsville, but the irrigation mechanisms, the harvest mechanisms, and the controls are more commercial grade.
Take me to the future. Where are you in 5 years?
In North America, I think the lagoon-based upgrade market is going to be a big part of it. Plants up to 5 MGD we think are good candidates. Beyond that, the space we need is probably going to be challenging from a real estate perspective on wastewater treatment plant sites. But small, medium-sized operations, this can be the way of the future in terms of nutrient removal for plants that weren't designed to do it in the first place. In Europe, I think there's a very interesting opportunity with the European Wastewater Framework Directive. They've downloaded nutrient limits to plants from 2,000 to 10,000 PE and are imposing an energy neutrality cap. So all these plants need to find a way to remove nutrients when they weren't designed for it, while not increasing their energy usage. And frankly, algae is purpose-built to do that. It's a low-energy nutrient removal. In the long run, this allows a shift towards a different mindset in water treatment, where we can probably shift to a higher intensity primary treatment to remove BOD and solids in the front end, and then only keep the nutrients for the secondary treatment process, and use an algae-based system to polish the nutrients, so you can get high bioenergy recovery off the front end and high nutrient recovery off the back end with the help of algae.
Well, thanks a lot. Looking forward to see the neighbor one to me in Vancouver.
Let me know when you're available, and we're happy to host you.
Sometimes a booth design can be very telling about your marketing budget, like the one behind me, especially if you compare it to the EPA from last year. Tell me your budget got cut without telling me your budget got cut, right? But that set aside, let's go to more serious stuff and let's talk of the do's and don'ts of trade show marketing. So one thing is a classic in a trade show like WEFTEC. You'll see booth teams at the opening time in the morning making the picture of the day to then share it on LinkedIn with a copy along the lines of "Come see us at WEFTEC in the South Hall booth number 7321. And I picked that number randomly. I'm not singling anyone out. Everybody did that. I even took some of these pictures myself. Now, let me ask, what's the efficiency of such a post? It doesn't trigger interaction, so it doesn't go very far in terms of reach for people not there. And at the same time, I don't see the use case of someone reading that and thinking, gosh, I need to hop on the plane for Chicago. Bob is on booth 7321 and I need to go see him. But I believe just a few twists would go a long way for that post to finally be useful. 3 ideas here. 2 I've seen on the floor, and 1 I would believe can make the final difference for companies exposing. Level 3 is what I've seen at many booths, enabling your visitors to win something. Trigger an action, reward it with a draw. At Xylem, you could pocket a signed jersey from Manchester City. At Aqua Membranes, you could win a pilot. Same idea, it works, but mildly, I'd say. Now, level 2 is what I've seen at Mentor APM. Still, ask your visitors to do something. In this case, take a picture with some colorful swag, but instead of expecting them to do something, do it proactively. Jennifer Zach was taking the pictures, publishing them on LinkedIn, and tagging the people. Hard for any visitor to resist the bait and not interact with that. And just like that, you've strongly expanded your online visibility, and it still doubles down as a draw. But I believe you can push the concept one step further, especially for the ones that are not at WEFTEC. I mean, many companies have used the show to launch something. So what if you'd still do your team's picture in front of your booth's key message, but now you double it with an irresistible call to action? For instance, you could be tagging your product manager and your CEO and ask, as we're launching this, let's say PFAS destructor, we're wondering who's done the most work to make it a success. Thumbs up if you believe it's Jane, our product manager. Comment if you believe it's Joe, our CEO. The friction is higher for the comments, so there's a solid chance your PM wins this one. At the end of the day, your CEO can come and comment on the post, admitting your PM won in a heartfelt message, which in turn will get its fair share of visibility and garner quite some likes, I bet. Along the same lines, you could commit to give $1 to a WEF charity for every like, or commit a push-up of your CFO for every comment. Yeah, I'd like to see that C-suit sweat. Long story short, here's what I believe most exhibitors can still do better. Think of the online resonance of their physical storyline as the same thing in the same continuity, with just the right triggers to help the social algorithms to help you. And with that little piece of advice, it's time to conclude my top 5. Finally, for my number 1, you'll tell me if it's more of a technical innovation or a business model innovation, but in any case, it's an impact innovation. Let's look at Crew Carbon.
My name is Joe Kachanoff, and at Crew, we developed a technology that improves the efficiency of wastewater treatment making it more efficient, cheaper, all while capturing greenhouse gases. So think of CO2, nitrous oxide. The next level in, which is probably what you might be asking, is how do we do it? We use globally abundant, naturally occurring, soluble calcium carbonate, and we dose it directly into wastewater treatment facilities, directly into biological treatment, where the calcium carbonate reacts with and dissolves in the presence of CO2, converting the CO2 that comes from the biogenic emissions of the little microbes, turning that CO2 into stable bicarbonate, all within the bounds of the wastewater plant.
Calcium carbonate is what you have here, right?
Right, yeah.
That's the powder.
Yes.
And you just drop it in the biological tank and that's it.
Yeah, effectively, at a very simple level. Yeah, so we design and build systems that holds the mineral that we source locally to the facility. Think of a vertical silo or a horizontal mix tank that holds the calcium carbonate and then precisely doses it directly into biological treatment.
But it's really like that. It's like the powder goes into the tank and that's it.
Correct. Yep. And then it dissolves, completely dissolves, so it doesn't form a solid. Similar to how sugar dissolves in your coffee, calcium carbonate will dissolve into the wastewater. That increases the pH and increases the alkalinity, which is really beneficial for biological treatment.
And what is proprietary in that?
One, we have several patents that covers both the apparatus, so the pieces of kit that come together to make this process happen, and the process itself, the dosing part, as well as what are the sort of steps that are required to use calcium carbonate to turn CO2 into bicarbonate.
Tell me more about that one.
To be able to use calcium carbonate, you need to have a pretty deep understanding of the type of calcium carbonate that you're using. That's the chemistry of it. There's different types of calcium carbonate, as well as the size of the grains to make sure that it is soluble. So if you were to source any sort of bulk calcium carbonate from, I don't know, the store.
Do they sell that at one of those fancy grocery stores?
It probably wouldn't work because you need to have a sort of next level understanding of what types of calcium carbonate actually make this process happen effectively.
You said locally sourced.
Yeah.
You have like the specific specs of how that should look like.
Yep.
And then you go shop around and you see what's within direct vicinity of the plant and that's what you source. If I'm not mistaken, that's only half of your innovation because you also have a business model innovation.
One of the things that I think is unique to our approach is that because we can remove carbon dioxide, right, we effectively can monetize the climate impact of our solution, which today we generate carbon credits that we sell to large corporates and governments. So think of big banks, big hyperscaler technology companies that are procuring our carbon credits at a pretty elevated price, hundreds of dollars per ton of CO2 removed. At the same time, we're optimizing the treatment process, which we sell as our services directly to the utilities. So it's just effectively a dual solution technology that gets us paid from the utilities, but also paid on the carbon credit side.
Carbon credit sounds like something complex, but understandable. Like you get it, you trade it. How do you optimize the treatment?
By effectively keeping pH and alkalinity at an optimal level 24/7 and 365, that improves biological nitrogen removal. There's a direct link between nitrification efficiency and pH. It's canonical, right? There's a figure that we've all known and read about in the textbooks, and we enable that. And most utilities wouldn't, right? Because maybe they're looking to minimize the input of chemicals, maybe minimize the costs. But because we're generating carbon credits, we effectively can subsidize the addition of alkalinity and keep these plants running in conditions that are optimal for biological treatment through the subsidy of the carbon credits.
Does every wastewater treatment plant fluctuate and move and drift, and so would benefit from a pH adjustment? Or is it really the ones which are not in a good shape?
Yeah, it's a combination, right? So we work with utilities that use alkaline chemicals today, right? Those are the most obvious, right? Think of like sodium hydroxide, magnesium hydroxide. We come in and we replace the usage of those conventional chemicals, and there's an obvious value prop there because we can offer alkalinity cheaper than what's available on the market. We also work with utilities that don't use alkalinity today. Maybe they're just getting by in terms of their process performance, but by optimizing pH and alkalinity, we can even take them to the next level of treatment and really ensure that they stay within compliance, especially in the broader backdrop of treatment requirements increasing in terms of their strictness for, nitrogen removal or phosphorus removal.
How did you grow up your business model, which is pretty unique? Like you woke up in the morning and said, hey, I'm going to sell carbon credits, or was it an evolution?
It was an evolution. My background really is understanding how we can use alkaline minerals to remove CO2 from a range of environments, rivers, oceans, agricultural systems, because there are gigatons, billions of tons of CO2 that go through Earth's water cycle every single year. One portion of the water cycle is the water and the pollutants that flow through wastewater. So it became very obvious to us that if we were going to use alkaline minerals to capture greenhouse gases, the wastewater application of our technology made a lot of sense because we're tying into existing infrastructure, we're tying into closed engineered systems, so it's very measurable, and we're solving real operational pain points. So it's not just carbon removal for the sake of carbon removal, it's really this dual solution solution that I keep talking about that really sort of proved to us that this was the right market to go into.
But let's go to the bottom of that dual solution and that business model. That means that as you're selling the improvement of the process and you're selling the carbon credits, you're not on top of that also selling the equipment. So the equipment comes in as a service and you are then getting paid on the two ends. How do you finance that? That must be super expensive.
A couple models that we've deployed today, which is, we can provide unpaid demo and sort of prove in a very short period of time just how we can improve the treatment process. And at the same time, because we're operating at scale, we're already making an impact on the carbon market side of things. Even though we have maybe an unpaid demo initially, because we're able to valorize the carbon impact, it's not unpaid for crude, if that makes sense. So that's kind of how we're able to finance an unpaid demo for the utility, but it's actually, we're still making the value from the carbon credits initially.
You say deployed at scale, where?
We are operational at 6 utilities, mostly up and down the east coast of the US, and actually 1 in Europe. And now we're sort of moving westward in the United States and continuing to evaluate how we could expand in Europe.
What is your vision down the line? Is it like to demonstrate that is doable and then to license it out, or to build like a huge company which is present everywhere in the world and creates carbon credits?
I think we have the interest and desire to potentially evaluate both. I am the founder of this company, and I think it would be silly not to have big ideas of grandeur and seeing this becoming one of the biggest carbon dioxide removal company in the world. And whether that means us going it alone and sort of building it organically and doing it ourselves, or potentially working with the right partners and licensing this approach to enable at scale. We're open to both. We're kind of evaluating both as we speak. And so I think time will tell, what path makes most sense for us.
I have a total muggle question. Carbon credits, is it something which is like stable in time, which is like evolving a lot? Is it something trendy with the current administration? I don't know. I read from an outsider perspective.
The carbon markets are maybe segmented into sort of 2 views. So on one hand, there is what's called the voluntary carbon markets. So these are mostly corporates who have their own climate goals that they're trying to hit by 2030, 2040, 2050. Many of them have done as much as they can to reduce their carbon footprint, changing light bulbs, moving to different forms of public transport, changing the type of energy that they source and utilize. But because the businesses are the way they are, there's still going to be a gap in getting to carbon neutral. And to fill that gap, they need to procure high quality carbon credits. And when I say high quality, I mean these are carbon credits that are removing CO2 from the atmosphere, storing it permanently, so more than 1,000 years, and storing it in a very measurable way.
High quality, you got the definition, but is it like a trademark, a copyright, a referenced something with a certificate? Who says it's a high quality?
So there are now multiple third-party registries and verifiers who are in place where they've established protocols that defines what is high quality, what is durable, what is measurable. And so we work with some of these registries today under a protocol called the Wastewater Alkalinity Enhancement Protocol that literally tells you the steps that are required to meet that criteria.
Reverse engineer that. What happens in the next 12 months?
The major focus is deploying this technology across as many utilities as possible. Our goal is to remove as much carbon dioxide as possible as quickly as possible. And that's, projects that we're developing currently with some of our utility partners, as well as some of our channel partners here in the US, but also in Europe. So we're contracting with a few utilities at the moment. Once that contracting is in place, signing the dotted line, building these projects and actually deploying them over the next few months. We have a pretty exciting and robust pipeline in addition to the 6 utilities that we work with today.
Let me take the converse of that. Why would a utility not sign with you? They get a better treatment of their plant. They don't need to put money down because you do that. And then on top of that, they have like the best PR there is because now they become a carbon sink.
Initially, they don't put money down, but for many of the utilities, we do, after the demonstration period, move towards contracting with them where they will eventually pay us, for the equipment and the mineral input, but again, much cheaper than what is available in the market, I should say. But in terms of your question on why don't they say yes, there are some utilities where maybe the process doesn't require this input, right? And they're operating in such a way that there's not much more room for optimization. That might be a reason why there's not a good fit. For us, one of the criteria that we look about is size, right? So the economics also need to make sense for us. And proximity to our supply chain is also something that might mean that we don't want to partner with that utility because the projects don't make sense.
And in terms of size, what's the sweet spot?
On the municipal side, 10 million gallons per day and larger. Multiply times 4, so 40 to 50 million liters per day. We've only been in business for about 3 years, and that, to be able to be deployed at 6 utilities in 3 years, I think is lightning speed for...
We're just on the other side of the BlueTech pavilion. You take the BlueTech theory, you are not even an outlier. You don't exist in the charts. It's like crazy fast.
Right. And I think that's a testament to the value prop that we, offer these utilities.
You said several times for utilities or for municipal, because there's also an industrial case.
It's made sense just how we've gone to market to focus on the municipal space, but absolutely industries that have a organic component to their waste. So think of food and bev, aquaculture, dairy, pulp and paper. There's absolute possibility for us to integrate into their operations as well.
Thanks, Ed, for the short of it. We need to have like a full conversation down the line.
Thank you.
And that closes my top 5 for this year's WEFTEC. If you believe I've really missed an important technology, come shout at me in the comments. I'd love to correct any omission. By the way, and while I'm at it, if you're enjoying this piece of content, you can help me tremendously to spread the word by booping the like button or by sharing it with a colleague, a friend, your boss, or your team. And if you're fond of technology, this is not the full extent of what I've recorded this year at WEFTEC. I also sat down with the entire Ovivo team to discuss their future and next steps. That's a full episode in itself, and it will come out later, so subscribe if you don't want to miss it. But for today, we still have a big piece to cover with water and AI, so let's open that last chapter right after I tell you about Starbucks. Day 3 is a bit less crowded. How do I know? Well, day 1, the lane at Starbucks looked like that.
And that's a lot of people.
Day 2 looked like this.
It's even more ridiculous.
And today, it's pretty manageable, but let's go back to serious stuff. Let's talk AI. For the 3 days of WEFTEC, there was a focus on AI right behind me in the Water AI theater.
We're taking a different approach. We're looking at both what water can do for AI and what AI can do for water. And we've got a great partnership. WEF is a convener. We bring everybody on board. We get a great partnership this year, supported mainly by Amazon. It's really going to be amazing, the center of excellence that we're launching.
And even though from time to time they had a party pooper raising a weird question,
if the water use of AI is in total less than a big desalination plant in Middle East, if the total use can be covered with solving non-revenue water, doing more water reuse, why do you spend 3 days talking about it? It sounds like business as usual.
Obviously, it's concentrated in the places where data centers are being built. You can't just build one big desal plant and supply that entire new data centers from that one desal plant. We've never had customers like this before.
I think it's a great question, but the reality is that water problems are global issues, but water solutions are always local. 3 days is barely scratching the surface. We're just going to get started here, but I guarantee you this is going to be an ongoing topic for a long time to come.
I think you should be a little bit patient. When you have such a partnership, you can not just talk about it, but you can also fast-track implementation and leading and trying to see how it goes.
It would be an understatement to say that AI was just present at the show. In fact, you could see it on so many booths. And among those new use cases for AI, there was one introduced here in partnership between WEF and Global Water Intelligence. I got to have a peek view behind the scenes, so let's have a look at that.
This is something that we've been working on for a long period of time. We were speaking with Ralph and Ray at WEF, and they got very excited about the product.
This is our minimum viable product that we've just launched. The full-scale version is coming January 2026. And this is the dashboard. So you can see some key figures from the kind of data we cover. We cover information on over 1,000 utilities in the US, information on 44,000 active projects, and that represents a sector capex of around 68 billion for 2025. Now, WIN is essentially a platform that connects capital improvement plans, council decisions, and also state funding applications in a way that allows you to preempt future project activity. We have our monthly roundup here for August, which is a selection of the key headlines. And on the right here, we have the latest files that we're processing.
This data that we're tracking is incredibly fragmented, spread across tens of thousands of different websites. AI was the last piece of the puzzle, which allows us to sort of take all that unstructured data and match it in a way that works.
It's not just taking utility documents, dumping them on ChatGPT and expecting a magical output. There are lots of secrets to how we pre-process the data, how we prepare the data. I mean, if you see some of these CIP plans, they're completely horrible in terms of format. As a human, it's often very difficult to understand what's going on. So we've had to develop a lot of internal tools to get the data in the best possible shape before we even start to think about using things like AI. And we also have to use a lot of our internal GWI knowledge to categorize projects by technology and application. And then we have a mapping process. So we take a project, we take a utility decision, and we have to make sure with high confidence that we can tell a customer that this particular contract award, for example, is related to a specific project. We have around 10 steps that specifically use AI, but throughout the process there are kind of clever tricks and trade secrets that we think give us an advantage in making sure that one, the data is accurate and it's scalable. You know, we've launched this with 1,000 utilities at the moment. If tomorrow we had to scale up to 5,000 utilities, we have the infrastructure, we have the pipelines in place to make that a reality. Document pre-processing is the most important step. With AI, if you feed it garbage, you get garbage out. We need to verify that each input and output throughout the data pipeline is running accurately. You know, AI models hallucinate. It took about 2 years to set up. We started when the AI models were terrible, right? ChatGPT 3 or whatever it was. Now we have fantastic models that have got cheaper and better.
Give me the specific. Like Corpus Christi is delaying its desalination plan.
This was a 50 million...
So if you click on it,
if I click on this, it takes me to a very long-winded Corpus Christi Council decision about exactly what happened here. Members voiced concerns about total project costs. You can actually find the original decision that was made. It links to the native file, provide as much information as possible, and then we also link to supplementary resources that help you better understand.
You can always navigate back to the original source. What this allows you to do is to get insights ahead of the tenders often.
We're trying to become the Internet of Water for the US. We want to tell people what's happening, what decisions are being made, and we want to let people position themselves for future projects. What we are trying to do is give people the best possible information to anticipate an RFP that might happen next week, that might happen next month. We have a list of all of the contract awards that were announced here, the contract amendments, financing update. And if we click on a specific contract award, when the minutes document is released for this specific meeting, our scrapers get to work. That little icon on the minutes lines up. We try to capture as much information as possible. Using AI every day makes you realize how important humans actually are.
We'll be applying AI across all our product portfolio. AI will help us to do what we're already doing better and more efficiently and in more detail. But I don't think that we're such AI experts that we're going to sort of start becoming an AI consultant. The way we want to be seen is as a sort of a human wrapper for AI, because I think that people have this sort of sense they're being told that so much is possible, and that makes them feel quite a lot of pressure, fear of missing out. We should be doing this sort of stuff. But the reality is, as Luke was saying, what I can't over stress enough is how many times, we ran into what we thought was a complete brick wall on this, and we thought this is not going to work. And Luke and his team did an incredible job in always, you hit a brick wall and you tunnel under it, or you go around it, or you just knock the wall down. The plan is certainly to have a natural language interface that sits on top of everything, so people will be able to interrogate it. There's no such thing as unstructured data. So when our people are writing, they'll have an AI agent that sits next to them, which is categorizing this. Our USP at GWI is, we speak to people. Our edge in the market is that we know everyone and everyone will talk to us. Soon, the AI will be able to know everything on the internet. Where we feel we add our value is putting real quality new information in through really speaking to the industry. There will be more AI interfaces, but we have to really work on how that data is handled in the back end. And that's what we have our sort of smartest people working on at the moment.
We cover around 1,000 utilities. That represents around 44,000 total projects that we have information from.
This is just the start. So this is just our sort of MVP for WEFTEC. At the moment, it's only municipal utilities. We'll be adding investor-owned utilities in Q1. The front end will bloom like wildflowers in the spring in the coming months. Because the AI is set very conservatively, you will have projects where there are no technologies referenced. You may have an advanced reuse project, but there's no technologies. That's just because the CIP or the decision did not specifically mention those technologies. What we will add is AI being able to say, we think that these are relevant technologies. So if you're looking for ultrafiltration projects starting in 2027 or something, the AI is set extremely conservatively. So it's only for exact matches.
Let's run down the use case. I'm a business development representative for a supplier of Jacobs. I have a meeting with Jacobs. I enter the platform. I look at
everything they've won, and then they can discuss those projects.
Yes. Or companies are quite excited about being able to track their competitors, I think. For them to be able to look and see, oh, this is what Jacobs won last week, this is what Stantec got, this is what, AECOM got, is quite an interesting use case. This is only the start of this.
When does it roll out to all your customers?
It's available now. People can access it immediately.
Like I can access it?
You can. We'll have a look.
If I do a cool video, will it get included in my...
I have to check.
Thanks a lot.
WEFTEC ever.
That's it for today. I hope you enjoyed it as much as I did. If you're a WEFTEC aficionado, see you in New Orleans next year. And if you'd like more coverage of water tech news and commentary, make sure to like and subscribe. You can also share this video with a friend, a colleague, your boss or your team. Your support goes a long way. Thanks a lot, and I'll see you next time.
Antoine, whenever you listen to that, and whenever you see that,
My
I need
is that cool.